Welcome to Study Loop.
Okay, question given is we have a spring with mass subtended to it, it's 2 kg. So we have spring with a mass m has 2 kg and damping constant c, which is 14. So let's say we have here damper, that is c equals to 14, and the force required to stretch the spring by 0.5 meters is 6 Newton. So we know force is kx. So force given is 6, k we need, and x is 0.5. So we get k as 6 over 0.5, which is 12. So that's k is 12. Okay, and some initial condition is given which is required when we'll solve for the solution. Okay, so let's start. So we know like general equation for such kind of system. Okay, so let's have this system is m d square x by dt square, where x represent displacement and t is time, plus c times dx by dt plus k x equals to 0. Okay, so now we can replace this entire thing by some new variable. Let's take it as, let's dx by dt as r. Okay, and this one will be r square, since we need a solution in general. Okay, and we are given m as 2, so this becomes 2 times r square plus c is 14 times r plus k, which is 12, and since it's x, so we don't have to substitute, so it will become 1. Okay, equals to 0. So now we have a quadratic equation which can be solved easily. So first we'll divide by 2, since all the numbers are multiple of 2. So this will become r square. 14 by 2 is 7 and 12 by 2 is 6, equals to 0. So 7 can be splitted such that addition gives 7 and multiplication gives 6. So that is 6 plus 1, and 6 into 1 is 6. So r plus 6 and r plus 1 is equals to 0. Okay, so we gave r as minus 6 and r as minus 1. So therefore a general solution will be x with respect to time will be c1 e raised to minus 60 plus c2 e raised to minus 1t. Okay, so now we have a solution, general one. So we need value of c1 and c2. So two conditions are given. First, x at t equals to 0 is it's how much? It's 1. So that's 1 meter. And velocity at t equals to 0 is 0. Okay, and velocity is nothing but differentiation of displacement with respect to time. Okay, so let's substitute, first differentiate this equation. So we'll have x dash, which is same as dx by dt, is c1 times e raised to minus 60, differentiation is e raised to minus 60 times minus 6. Similarly here we'll have c2 times e raised to minus t times minus 1. Now we'll substitute this boundary condition. So first one, at t0 x is 1 meter, so we'll substitute that here. So at t equals to 0 x is 1, so c1 e raised to 0, since 0 times 6 is 0, and c2 e raised to 0. So we get 1 is c1 plus c2. And second boundary condition here, So x dash t is velocity, which is 0 at time t equals to 0. So this will be minus 6 c1 e raised to 0 and minus c2 e raised to 0. So this is 0 minus 6 c1, since e raised to 0 is 1, and this is c2. Okay, so we have two conditions or two equations. We can solve that simultaneously and we'll get c1 as minus 1 over 5 and c2 as 6 over 5. So therefore our solution x with respect to t is minus 1 over 5 e raised to minus 60 plus 6 over 5 e raised to minus t, and that's a final solution.